Or he could help us. Make sure Hoffbauer's doing it right. All right, guys, we are going to look at normal distribution again, starting with worksheet 12. And then the goal is to get to a few of these SAT prep kind of questions. Miss Abruzzo went through a bunch of different tests and pulled out stats-like questions from the practice SAT test, just to show you that there's a lot of stats on there, okay? And some sample questions. All right, I need to back up here. I was going to redo this question. We did this question. We learned about empirical formula, or I taught about empirical formula. I'm not sure anybody learned anything on the last day before spring break, but do you remember empirical rule was this rule that said if you go out one standard deviation either way from the mean, that would encompass 68% of the population of whatever you were doing here. If you go out another standard deviation, that hits 95, and if you go out 3 either way, you've hit 99.7. Okay, so this question was following that rule. It said if we have 200 trees total in a nursery with a mean of 120 and a standard deviation of 16. So I need you to add and subtract 16 real quick for me. So that would be 136, another 16. Okay, and going this way, if we subtract 116, and if we subtract 16 more, I think we're down to 88. Okay, approximately how many trees are more than 136 inches tall? So that's saying above this. This is half of the data over here, 50%, and this was 34%, right, on the empirical rule. So we want above that. So above, 84%. So what does that leave, guys? What percent is above 84%? So that leaves 16% of the trees, which in this case, how many trees did we have? So it's 16% of the 200 trees. So about 32 trees would be more than 136 inches. Okay? And then this one really in my book is easier because it's just asking the percent. What percent falls between 88 and 104? And that's just this little piece in here, which if we go back to this chart, would be this 13.5%, right? Okay. That's all they were asking here. All right. I want to do one more question on standard deviation or on using the empirical rule. This was number 2 on 14A. It was a homework question. I doubt anyone actually did it, but just pretend with me. This is using the empirical rule again. It says Dion commuted 290 miles each week for work. His car averages 29.6 miles per gallon with a standard deviation of 5.4 miles per gallon. Assume the data are normally distributed. Approximate the number of miles that Dion gets a gas mileage of 35 or better. So I want to draw this real quick because this is using exact here. It says his mean is 29.6. Can someone add 5.4 a couple times for me? Yeah, and another would be 40.4. If we subtract 5.4, we'd have 24.2. Somebody be checking these on the calculator. Check off another 5.4, 19 point something. 24.2 minus 5.4. Thank you. All right. Approximate the number of miles that he gets a gallon, 35 or better. So what percent would be above here, guys? It's the same question we just did. This is 50% down here, right? And one standard deviation is 34%. So this is all of down here is 684, sorry. So above 84% would equal 16%. But it says approximate the number of miles. So if he's driving 290 of those miles, 16% of them, somebody give me that number. Should be around 40 something. 40. So out of the 290 miles that he drives each week, about 46 of them, he's getting better than 35 miles to the gallon, okay? For what percentage, so this time we just get to use a percentage, does his car have a mileage between 24.2, which is here, and 40.4, which is here? So go back to your the empirical rule on 12A, I think, empirical formula. This would be 34%, 34%, and isn't this one 13.5? So that's 68. Yeah, I think so. Anybody else add that up? 68, 78, 79, 80, 81.5. Yep. Okay. Now, why I wanted to do those two real quick is because both of those, everything about those questions landed right on those numbers, right? Right on those little standard deviation numbers. But what if I want to know, when he gets above 32? Is there a 32 going to fall anywhere in our actual standard deviations here? No. So when whoa, that's not what I want to do. Sorry. When we don't have an exact number of standard deviations that fall on the empirical rule, okay, it says it's only useful when evaluating specific values when you have the mean plus exactly 1 or 2 or 3 standard deviations. But if you have a part of a standard deviation, okay, then we're going to use what's called a Z-score. The Z-score basically is just the number of standard deviations that we are from the mean. That's it. How far, instead of being exactly one standard deviation away, maybe we're 1.8 or 1.04 standard deviations away, or we're below the mean by 2.3 standard deviations or whatever. So this formula will be on your reference sheet, okay? And it says to find the Z-score, you take whatever number you're talking about minus the mean and divide it by the standard deviation. In other words, how many standard deviations are you away? So, and by the way, a positive just means you're above the mean. Negative means you're below the mean by a number of standard deviations. So you have these two quick questions. There's something like this on the quiz when we get to having a quiz on this. But if you have the formula, it should just be an algebra question, right? So it says find Z if, and here's the formula. So we're going to plug those numbers in. Z equals 65 minus, this is the mean, 50, divided by the standard deviation of 10. So what do we get? Yep. And that's positive because our value was above the mean. Okay? So we're at a Z-score of 1.5. All that means is we're exactly 1.5 standard deviations above. But is 1.5 on our little chart? Remember this? This was the mean plus a standard deviation right here, or plus 2 standard deviations, but we don't have a mark at 1.5 standard deviations. Okay. And then this one is just going backwards. If you knew the z-score was negative 0.4, so you were actually 0.4 of a standard deviation below the mean, what was your score? So we're finding x. The mean is 40 and the standard deviation is 5. How do you solve that? Yeah, negative 0.4 times 5, and then add the 40 over there. Negative 2 plus 40 would be 38. Is that right? Okay. So if you knew you were negative, say the average test score was 40, and you knew you were negative 0.4 of a standard deviation below that, then your score would have been a 38 or something. Okay, just an example of why you would use that. Every normally distributed random variable has a unique mean and standard deviation, which affect the position and shape of the normal distribution. As a result, there are infinitely many normal probability distributions. Okay, what they are talking about is that if we take that normal distribution and we say that has z-scores has a mean of 0 and a standard deviation of 1, so they're just taking the z-scores instead of the percentages we were using a minute ago. So here is what it would look like from -3 to +3, and you could still apply the empirical rule, okay? But we're also going to be able to use z-scores that don't fall exactly on those integral values of -2, -1, 1, and 2. So you can use the z-score to approximate the area under a curve. And they get a chart in stats, but your calculator does it for you. So I don't really know why they use this chart in stats, but they do. The calculator does it a couple different ways. We are going to, you can either use z-scores or you can use the actual mean and standard deviation. So the default is set to use z-scores, but you can actually put in the mean and standard deviation as well. This is what we're going to use, normal CDF, and it is CDF, not PDF. PDF will just tell you the probability of hitting exactly one number, okay? CDF is when you want to combine all the numbers below there or above there. So what's the probability I get a score, below 17? Okay, then you want everything below there. So that's why you're using CDF. All right. I'm going to show you a couple different things on the calculator, and then we'll just do them all the same so that you don't get confused. You can also use the calculator to draw, and I'll show you how this works, but I don't really think it's the most effective way. This example I have says the average number of phone calls received by a customer service representative each day during a 30-day month was 105 calls, with a standard deviation of 12. So if we were to draw this, we'd have 105 and we'd add 12 and get 117. And if we subtracted 12, we'd be down to 2 would be 103, 93. Did I subtract 12 right, guys? And it says, what is the number of days with fewer than 110? Well, does 110 fall on one of these exact standard deviations? No, right? So we're going to find the z-score or not. They want us to find the z-score. So you would say, I have 110 away from a mean of 105 divided by a standard deviation of 12 calls. Okay, type that in and you get 0.42. So I want to know what's the chance that I fall below 0.4. So there's several ways you can do that. I just want to show you this one, and I don't want you to try this on your calculator necessarily because you really have to mess with the window, okay? But there's a way that you could put this in, and you would go in here and go over to draw, and I want to shade the normal, and I want to know, what was it again, guys? Fewer than 110. So I want to know from -4, if you're using Z-scores, you could just put a -4 there, wouldn't matter. Up to, and then what Z-score did we get? 0.42 to positive 0.42. Okay, let's see if this works. Okay, I'm a little concerned that I didn't see it drawing, but that's what it says, up to 0.42. Okay, so it says the area was 0.66, or 66% of her calls would fall in there. Okay. I just wanted to show you that it will actually sketch it, but this is what we're going to do. Everybody do this, go second and then vars, because we're using a distribution. All right, second vars. And do you remember which one I said we're going to use? Yeah, the second one, number 2 down here. Okay. Now, oh shoot. Did you all get a little stats wizard? I don't know why I didn't. It says it's turned on. Like a little, did you get this? Did everybody get this? I don't know why I got it this time and I didn't last time. Tristan, did you get this? Okay, go to mode and make sure the stats wizards are turned on. Okay. All right, guys. For this particular question, we said, what's the chance that they get less than 110 calls? Well, I'm just going to put 0 here because you can't get less than 0 phone calls, right? We want up to 110. I'm not using the Z-score this time. Between 0 and 110 phone calls, when the mean was, my mean was 105 with a standard deviation of 12. So I'm going to put in 105, and then I'm going to put in 12. And I'm just going to hit paste. And I got 0.66. Did anybody else get that? Did everybody else get that? Okay. So isn't that exactly what I got when I shaded it, was 0.66? Okay, it said underneath that curve is 66% in between there. It's just a nice visual to see it, but this will give us the same percentage. Now, I'm going to do this one more way, and you don't need to do this if you don't want to, but we could have gone in here and left it, whatever this was. I'm going to actually use -4 because 4 standard deviations below. Now, our Z-score was, what was the Z-score here? 0.42. Okay, so we could have put our upper Z-score as 0.42. And if you were doing that, you would say the mean is just 0 and the standard deviation is 1, because that's using Z-scores. Remember, it showed 0 in the middle and then it's 1 above or 1 below. And then if I did this, it's going to give me the same thing, roughly 0.66. Okay. Now, they use these scores all the time in stats, but I would rather just plug in the numbers from the problem and not have to find the Z-score. Does that make sense? Okay, so back to the question. It said how many days? Well, 30 days in the month. So 66% of 30 days, can someone do that for me? Looks like I have down here, it's 19.8. Or about 20 days, okay, with fewer than 110 calls. All right, so let's do the ones that are on your worksheet. Do you have this one? But it's already done for you, right? Let's go straight to this number 4. Is that okay? At a restaurant, the average time between when an order is placed and when the entree is served is 12.5 minutes. So that's our mean. And the standard deviation is going to be 1.2 minutes. Out of 100 randomly selected customers, how many will be served within 14 minutes of ordering? So I just want to go back to this. If we were doing this, it would say 12.5 minutes, and you'd go up 1.2, or you'd go down 1.2. Somebody help me. Is that right? No? 11.3. Thank you. Okay, but the question says within 14 minutes of ordering. So we want everybody who got their food before the 14th minute. Do you see what I'm talking about? Okay, and it's not landing right on one of those standard deviations, is my point. So we want to do norm CDF, but what is our lowest? Well, we could figure out what 4 standard deviations below was. Yeah, can't we just do 0? You can't get your food faster than 0 minutes, right? Or sometimes you can even put like -999 there, it won't matter. And the top, we want everybody who got it within 14 minutes. And then the standard deviation, or the mean, I'm sorry, is 12.5. And the standard deviation is 1.2. So I want to do one more time for you this draw thing, just so you can see this, okay? If I did it with a draw, and I left that, and I said this was, what was it again, guys? Help me. 14 with 12.5 and 1.2. Did I remember all those numbers? Okay, so this says 0.894, and it shows this is everybody below 14 minutes. Okay, what I'm not suggesting we use that draw. Like I said, it's a pain to find the window that works. But if we did this, we want 0 up to 14 minutes where it was 12.5 and 1.2. Is that what we did? I won't keep showing you 2 different ways, but 0.894, is that what I got a minute ago when I did it on the draw as well? All right, I think that's not the question though, because this one didn't actually ask the percent, did it? Yeah. 0.894 is 89.4%. So out of 100, about how many would get their entree? About 89 people. 89 people within 14 minutes. Okay? Everybody good? All right. Number 5 says Ms. Kwan, a full professor at a community college, earns a salary of $48,600. The average salary for a full professor is $52,000. So this is our mean with a standard deviation of this number. Okay. How many of the 45 professors earn less than she does? So we want to know what percentile she's at. That makes sense? Now, if we did this as a Z-score, would it be positive or negative? Yes, because she's below the average. Does everybody see that? I'm going to show you with a Z-score one more time. So her score or her salary, somebody help me here with the math, from the average divided by the standard deviation would give us a z-score of what? 4600 minus 52,000, enter, divided by 3,600, negative 0.94, repeating, okay? So I could go back here and I could use that and do these all in z-scores. I would say down to 4, they usually use -4 z-scores as the lowest, negative 0.944, whatever you want to put in there. And when we're using z-scores, remember, it's 0 and 1. I don't know why that's what they always do, 0.172, okay? But again, I don't like to do them that way. I'd rather not even have to find the z-score. So if we went back here and said the lowest salary, we could put 0, to her salary, which was what again, guys? Okay. When there is a mean of 52, was that right? And 3,600? And I still get this 0.172, and it's slightly different. And actually, in my thinking, ours is more accurate because here we had to round that 0.944 at some point, right? So it doesn't really matter. 0.172 is fine. So she is at the like 17th percent of the people are below her. So she wants to know how many actual people that is. Well, of the 45 people that work here, if we multiplied, it was actually 172. If we were being a little more accurate, times 45 is what? Okay, 7.7. So between 7 and 8 people, somewhere in there, are below her on the salary schedule. Making sense here? Good. All right. I promise I'll stop doing them 10 different ways, okay? How many, during 1 October, the average water temperature in a pond was 53.2 with a standard deviation of 2.3. How many days was the temperature greater than 50? Okay. So what are we going to put in for our norms, CDF? What's the bottom score we want to use? Yes, because we want greater than 50. So we're going to put in 50. Okay. Now, we could do something fancy for the top and say I want to go 4 standard deviations above. Okay. So you could say the standard deviation is, or the mean is 53.2. I'm going to add 2.3 4 times, and that's going to be roughly my maximum. Or we could just make sure we go above that. What do you want to say? Well, if the standard deviation is 2.3 and you did that 4 times, you'd have about 9 or 10 added onto this. Yeah, that's what I'm thinking. I usually just put like 999 or something, you know. So you could definitely go to 100. This number just has to be 53.2 plus 4 standard deviations or greater. Okay, if you want to know up to the top. And then what were we doing again? The mean and the standard deviation are the last 2 things we put in. All right. So norm CDF, we wanted above, was it 50, guys? Okay. And we said we're just going to put some number in here. And I can show you, I can do it a couple times with a different number and show you it won't matter. This is 53.2, and this was 2.3. Thank you. Okay, so I got 0.9179. I'm just going to go back in here and do this over, and I'm going to change this to like even 65, I think would have been enough. See, it's still the same number. Okay, if I'd put 0.999 or 999 in there, if I went back in and I changed this to 99 degrees as the top, still the same, right? So it isn't making a difference. Once you go out more than 4 standard deviations, it doesn't matter. Okay. Oh, what was the number though, Hofbauer? 0.918 roughly. Okay. Is that the answer they want? What do they want? That's the number of days. So this is about 92% of the days. How many days does October have, guys? 31, because it's a Halloween, right? 28.5. So around 28 or 29 days. Wait, I didn't. Oh. Okay. I really don't care. About 28 days, let's go with. If you wanted to give me an answer of 28.4 days or 28.5 days, I would be fine with that, okay? Number 7, the average age of the swimmers on a master swim team is normally distributed with a mean of 56 and a standard deviation of 4. Find the probability that they land between 53 and 59, or the probability they get less than 53. Just one more time. If we were doing this with our empirical rule, am I saying that right? All of a sudden I'm doubting myself. Yeah. We would have to go exactly up by 4s. And these numbers are not falling there, right? So we're going to do what we just did. We're going to do norm CDF. And guys, the reason you know to do this, I should be stressing this on every question, is these words are telling you when it says normally distributed, okay? You're not going to be able to use this unless it says normally distributed. Now, this is between 53 and 59, so there's our min and our max right there. Love this question. And then the standard deviation, or the mean was 56 and the standard deviation of 4. So anybody put that in already? 59, 56, and 4. What'd you get? 0.5. So looking down here, if you were talking about from here to here, now remember from 52 to 60 was 68% using their rule. And so we used a slightly smaller range and we got this. Is that making sense? Okay. Find each probability. I'm okay with the probability being a decimal or a percent. If you want to make that 54.7%, that's fine. And what do we want to do for less than 53? Do you remember how far it has to go? Well, it can go to 0, absolutely. It's just got to go at least 4 standard deviations. Okay, so I would be lazy and just do 0 as well. From 0 up to 53, with 56 and 4 being the mean and standard deviation. So we would be doing from 53 here and below, okay? And if this was 50% and this was 34, etc. But what did we get? Okay, looks good to me. Everybody all right? All right, now we're going to move on and talk about finding a specific score or given a percentage. So it says you found the area under the normal curve corresponding to a z-score, z-value. You can also find a z-value given a specific area. So if we wanted to find the middle 20%, like if I want to know, Miss Kwan wanted to know what the middle 20% are making at her school, she could use this kind of a situation, okay? So what we're going to do is called inverse norm because we're going backwards, okay? So on your calculator, it's the same place, and it's going to work in z-scores. So find the interval of z values associated with the middle 50%. Well, the middle 50% would mean you're at 0.25 below, because remember z-scores, this was 0, and then it went 1 standard deviation above. So if you want to know what is at the 25th percentile or below, or what is at the 75th percentile or above, so the middle 50% would be those scores in between there and there. So you'd do inverse norm 0.25 and inverse norm 0.75, but you would get exactly the same percentage. It says negative 0.67 and positive 0.67. Does that make sense, guys? Remember, the z-scores are the same on both sides. It went up by positive or negative. Okay, the normal distribution is symmetric, so when you're asked for the middle or outside, the z's values will be opposite. This says the outside 20%. Now you got to be careful because this confused me at first. I wanted to do like 80% and 20%. But if you're doing the outside 20% total, then they want 10% at the bottom and 10% at the top. Does that make sense? So they did inverse norm 0.1 and 0.9, which are exactly the same scores. This was negative 1.28 and positive 1.28 as the z-scores. All right, what are we going to do? It says the middle 25%. Okay, so you don't have this question either, do you? If you wanted the middle 25%, guys, you'd say, well, here's the 50th percentile. I need 25% total in here, so I'd go 12.5 above and 12.5 below. Does that make sense? So what's 50 minus 12.5? And 50 plus 12.5 would be, okay? And then you could make those 0.375. Let's just do this once. Inverse norm. Okay, go the same place and go down to number 3. Inverse norm. And we want 0.375. My calculator was not giving me left, right, center. Is yours giving you left, right, center? Or did I do something wrong? Your calculator, if you do inverse norm, does it give you left, right, center? Mine's not on this one. Inverse. I got a question. Did you get this left, right, center? Oh, do I just leave it at center? Okay. Okay. Ah. Okay, so we should just leave it at left? Okay, thank you. That would be a no. All right, so let's go to the questions we actually have. We're spending more time on this. The middle 60%. Okay. So if here is 0, what's going to be the middle 60%? Be at 30% on either side, right? So we're going to go inverse norm, which is number 3. And you want 0.3. Do I want that to be negative? I think I do. I don't know. I'm going to try this. So that's a negative 0.52. I'm like feeling less than confident that I'm doing this right all of a sudden. Oh, I know what I'm doing wrong. Okay. Let's try this again. We're trying to find a z-score. We're not doing a z-score. If this is the 50th percentile and you want the middle 60%, you want 30% on either side of that, which would go down how far? Yes. Does everyone understand why that's the middle 60%? Okay. I was doing z-scores and we're supposed to be finding z-scores. All right. So we're going to go inverse norm. Sorry, video, that was wrong, but I'm fixing it. And we want 0.2. And we get negative 0.84. And if we did the other one, we'd get positive 0.84. So the z-scores, okay, fall between negative 0.84 and positive 0.84. So less than 1 standard deviation on either side. The outside 30%, help me with this one real quick though, guys. Do you remember how this goes? It's 15% on either end. So you need the 15% here and the top 15%. 30% of the data, you want the bottom 15% and the top 15%. So if you went back here, they're both going to give you the same score. Inverse norm, 0.15. Is negative 1.36, and the other one would give you positive 0.136. So here you would say I need a z-score less than negative 1.36 or a z-score greater than 1.36 to represent the outside 30%. So find each probability. This is number 10. The cost of removal is greater than 150. So you would say norm CDF of 150 up to some really high number. Make sure it's more than 4 standard deviations above, with a mean and a standard deviation. And that's the answer you would put here. Okay. This one specifically says between 110 and 130. So you just do that. This one said between 90 and 100. Okay, so your assignment, guys, is to do worksheet 14. And tomorrow, I promise we'll look at some of the questions on those yellow SAT things, okay? Worksheet 14A and B. Hey, what's happening? What's good? How about you? Was okay. 2-8.
Yeah, stats class.
So 1.28 equals, yes, it is stats class. So if I work backwards, times 20 plus 120, 145.60. Have a good one, guys. Hey.